Good afternoon, ladies and gentlemen. I think we'll get started in the interest of time. So, my name is Dr. Vinod Gauba, and let me start with one number, 16%. Right now, only 16% of humanity is training more than 80% of healthcare AI, which billions are going to rely on in the future. Think about that. Most of the world is not even in the data, shaping its own future care. And entire regions remain almost invisible. If 16% sounds low, listen to this. The entire Middle East region currently contributes less than 0.2% of global genomic collaborative datasets. These aren't just statistics. They tell a story of who modern healthcare is being built for and who it risks leaving behind. They expose the foundations of precision medicine, drug development, clinical guidelines, AI systems that simply do not serve or reflect the diversity of humanity. And when people are missing from the data, they most often are missing the solutions. For me, this isn't theoretical. 8 years ago, my father received a genomics-guided cancer therapy that didn't match his biology. Not because the science was wrong, but because the data behind it didn't include people like him. What was predicted to be a very helpful treatment ended up being very harmful. And this experience really shaped the last decade of my work, leading to the creation of GeneVault, which is a public benefit corporation built around a very human idea that every population should be able to contribute to and benefit from the science of the future, while still retaining ownership and control of their data. And since then, we've had the privilege of working with numerous data stewards across the globe, helping to make them visible and discoverable to the biopharma industry and to the AI developers of future models. Not by moving their data, but by ensuring their populations are finally countable, represented, and part of the scientific conversation. And this isn't just a technical challenge. It's a question of fairness, of dignity, and global equity, of who gets seen and who gets included, and ultimately, who is going to be served by the healthcare in the future. And that's why today's conversation matters so deeply, not just professionally, but personally. And so it's a real privilege to be joined by three remarkable leaders who are helping shape the future of global genomics. Albarah El Khani, who is the COO of M42, leading one of the world's most ambitious genomic and AI-led precision health initiatives right here in the United Arab Emirates. Professor Ma'n Zawati, who's joining us from McGill University in Canada, who's a leading legal scholar in health data governance and is the co-chair of the AI working group at the Global Alliance for Genomics and Health, where he helps shape global frameworks for responsible AI in genomics. And Yusuf Henriques, who's the founder and CEO of IndyGeneUS Bio, leading one of the most ambitious Africa-driven efforts to build genomic inclusion and community-powered health innovation. Thank you all for joining us. So let's start with where we are today and what the lack of representation already means for science and clinical care. You heard about my personal experience, but that was 8 years ago. I'm the N of one, maybe I'm an exception. Why does it really matter? So Albarah, given that you're sitting at the helm of one of the most impressive genomic initiatives on the planet, talk us through how the UAE is effectively and actively addressing potential gaps or limitations that arise when such regional or localized populations aren't represented in global genomic datasets?
First of all, thank you for the invitation. I think, to your point earlier when you said 84% of clinical trials are conducted on, I think, 10% of the world's ethnicity, that truly addresses the major gap we have in the inequity in the way we conduct medicine from clinical pathways and precision therapeutics. In simple terms, we are creating medicines for few and not for the many. So the UAE government took a bold move about 4 years ago to see how we can address the inequities in the global south by providing data that can be utilized to address that gap. Also to look at how we can use that existing data or that data we're going to produce for the benefit of their citizens. So it had two objectives. Number one, serving the nation to improve health and benefits of outcome using what we call the three P's or models of care: the prevention, prediction, and precision models of care. And number two is how we can support in keeping this data to be very sovereign and secure, but allowing access for insight generation to expedite the discovery process and supporting the initiatives to reduce the gap in the global south. Today, I'm very privileged and proud to be part of this program. We have conducted over 873,000 whole genome sequences, which is about 80% of the entire UAE population of citizens. That is a mammoth responsibility, but also it has so much benefit and value you can not just bring to the UAE, but bring to the entire global south. So for us, 2026 is a intersect of where we can start now utilizing this data on a global level, where insights can be generated and we can start addressing this inequity, where hopefully we'll be part of reducing that 84% down to a much smaller number. And bearing in mind, when we look at FDA, for example, they are focusing on much more diverse clinical trial data sets today. They've seen and they've realized the value and the need, forget even the value, the need of having more diverse data sets. Because truly therapeutics is not precise without understanding the biology it has on the individuals beyond the group that has been the part of the clinical trial. And they are pushing a lot more clinical trials outside of this small few to more of many. And Africa and Middle East is playing a significant role in how to address that inequity.
Thank you. That's very inspiring to hear. Man, from a governance angle, how does underrepresentation today affect the reliability and fairness of decision-making in the clinical or other contexts?
Thank you. Thank you for the invitation. I hope you can hear me in the back. I think let's start with the first challenge, which is you are basically hard-coding inequity into science, right? So when you have models or algorithms that perform very well in certain parts of the world, but not so well in other parts of the world, what you're doing is you're creating scientific bias that will potentially lead to clinical harm. So that's number one. I think number two is you're creating also models that can't really travel, right? So if your algorithm or your model that you're building, you are basically unable to generalize it, then you're going to miss out and potentially create inequity in access, especially in low middle income countries. And I think this leads from an area that I'm mostly interested in. I think when you talk about inequity or the lack of diversity, what it does, it also undermines global policy making, right? So if you are unable to bring this technology in certain parts of the world, you're unable to also capture how society reacts to it. And how society reacts to it is the fundamental element or the fundamental foundation of policy making inside that country, inside that region. So when you have this inequity, basically you are potentially relying on policies, legislation, models of governance that are from elsewhere, that are not really local. And in a society or in a global perspective where you're hoping that every voice matters, when you have this inequity, you have a unbalanced global representation in policymaking. And I think, to some extent, I can synthesize all of this by saying you're really missing on a really important scientific and ethical opportunity when you have inequity.
Fantastic, great point. Yusuf, turning to you, what are the real-world consequences right now when African populations are missing from the evidence base driving global healthcare?
Yeah, no, appreciate you guys having me. So yeah, currently right now, as you just stated the statistics, what we're seeing is that Africa is going to play a critical role in precision medicine just because of genetic variability that comes from the continent. And so, you know, as what was eloquently stated before, if you're not including those data sets from the African diaspora, which, you know, the debate is, you know, life started in Africa. And so when you have one of the largest gap and blind spot that's not included with less than, like you said here, 0.05% representation, and we're talking specifically around gene sequencing, right? So that's what we're talking about, cell and gene therapy. So the word gene is very important to me, so that's why it's in our name of our company, because then what are you developing the cell and gene therapy based on if it's one population quite aggressively? And so, you know, 84, 88% of that data set is of one population, then you can see how the rest of the world wouldn't benefit from a therapy that's $2.1 million, which is what sickle cell is, right? But the prevalence is in the African descent African diaspora. So that's the bias and the inequities that start to arise because the benefit doesn't really transfer to the community that it needs to address, yet there's a high price tag on certain medications. So that's always where IndyGeneUS Bio has been focused. And to you, as your point, my daughters are losing their vision. So I'm a dad that's trying to save my daughter's vision. So I have twin girls that have retinitis pigmentosa. And unfortunately, when we were given the therapy that could help them, it was $450,000 per eye and zero efficacy in women and African-American descent. So the cost, the risk of paying the money is not even the benefit of the actual patient even taking this. Say you were able to get the funding to pay for this, there's no even true value, as you mentioned before. So that's where we saw the opportunity is to get more representation from the diaspora, specifically around whole genome sequencing, because that is the future of precision medicine. And in order to do that, we need to have collaboration across the UAE and Africa so that we can make sure that those genetic variability are also included when you're taking statistical data to the FDA, right, to getting those approval. Because again, without that data set, you're not able to get that therapy across the finish line. But right now, it's pretty much biased and skewed.
And you raise a great point that it's not even just ethnic diversity or admixture, it's actually even male and female. Because the majority of the Eurocentric data sets that we work off now are predominantly male. So that bias that Ma'n pointed out is at risk of baking in to our future of healthcare. So we've heard what underrepresentation means for science, for clinical care, and for people whose biology isn't reflected in the data. The next question, of course, is how do we fix it? What do we do? How do we collaborate responsibly in a world where sensitive data, like genomic data, can't simply freely move across borders? Albarah, how can countries like the UAE participate in global precision medicine while still maintaining strong stewardship of their national data assets?
It's a great question because these are the challenges that cross-border data aggregation has. And the major challenge is that this data is considered a national security data set in most countries, i.e. it has the same level of sovereignty and security as a police data set would have or any other sensitive data set would have. So with those challenges in mind, there has been many solutions proposed, and I think the most sort of environment that we see working globally is what we call a federated trusted research environment, which means technically that this data is sitting in a very secure nature. We have something called a 5-save system, whereby this data is sovereign, secure. But then there's a layer of a platform that sits on top of this data that interrogates the data. So let's say an academic, a farmer, would come on board, they would sit in this trusted research environment, they would interrogate the data, but they can't see the data, neither read the data, nor amend the data. But the insights generated from that interrogation goes back into the trusted research environment. So now they have the outcome of their interrogation without actually manipulating or reading the data set. So this environment now allows us to open the borders of data interrogation, data insight generation, but keep the data secure and sovereign. And that's how we're trying to address, and this is why I said in my previous comment was 2026 is a pivotal time for us, because we will be launching, hopefully with the Department of Health of Abu Dhabi, the trusted research environment, which will now allow academia. If you take the UK Biobank as a small example, when they open their data set, the exponential growth and the magnifying effect when it came to R&D and publications was immense, because they allowed access to data, and therefore, naturally and organically, this would generate insights that would lead to discovery, and so on and so forth. So this is the pivotal time we're in, and we believe the trusted research environment is the way to move on from a federated data set perspective.
Fantastic, thank you. Man, what standards or frameworks can help make cross-border collaboration possible without the sharing or exposure of raw data? Can you just talk us through that a little bit?
Yeah, definitely. I mean, one of my roles is co-lead of the regulatory and ethics work stream for the Global Alliance for Genomics in Health, and this is really what we do. We set standards, we develop policies, tools in order to be able to do this. So the focus here in situations like this, where sharing might be limited to some extent or not possible for a variety of different reasons, we shift from thinking about transporting data to sharing standards, tools, and policies. And the idea here, what we're trying to achieve is this interoperability, right? Because, you know, if you are going to be able to work and collaborate and bring this data and make it discoverable across different regions, you need interoperable tools to be able to do this, right? So this is where the standards and policies come into place. But their focus is really on good governance, right? Because this is, you know, at the heart of this is it's trust.
Yeah.
So you mentioned trusted research environment. You didn't say fancy research environment or cool research environment. You said trusted, because it's really at the heart of that. And that requires building very strong governance frameworks for a lot of these initiatives. The governance framework is basically the constitution of the program or the initiative. And this is how projects communicate between each other, is that they look at each their governance frameworks and then try to find ways they can work together. So if you're using common tools to be able to do this and common standards, it becomes much easier. It's not, you know, fully streamlined, but this is where we're hoping we can do this. And I think, you know, one area that is very close to my heart, and I really do believe in it, is capacity building. So I'm not just talking about tech and science, which is very important, but also in policy, ethics, and you know, general policy making. We need this. I mean, I'm personally from the region. So folks who are from here, I'm Wild Dira, as we say. And I really truly believe that in order for projects and initiatives to be well integrated and join other international you know, programs, we need to make sure that we have the local richness and policy making at the table as well, right? And to be able to think about equity not just as an afterthought, right? Really equity as an architectural design, because this is really at the base of all of this.
Absolutely, and I think equity has too often been an afterthought, so that's a very, very valid point. Yusuf, what does fair and equitable collaboration look like on the African continent, and particularly from a community perspective?
Yeah, no, good question, and I think my panelists that have talked to the idea of interoperability, trust, that's the same thing, right? So you're starting to see that across even in the U.S. as far as being able to have equitable access to healthcare. As you know, it's no secret, Africa is behind maybe 10, 15 years when it comes to healthcare, right? If you're in Africa, you may have version 1 of maybe version 5 of an equipment. So there's a lot of work that needs to be done, capacity building, right? The technology hasn't really moved through the continent as it has here in the UAE. And so that's one of the areas that needs to be, the capacity building needs to be there. Bright, young population, so that's not the issue, right? The workforce is there, but the training, the education piece of it, coming together to get trained the next generation of African scientists, because they don't have the tools. When I started IndyGeneUS, one of the first things we did, we looked across all of the continent to see where you could even do AI machine learning. And unfortunately, that was only in few places like that's highlighted on the map behind us, which was South Africa. Now, there's other places that are now getting into that space like Kenya and Ghana, but overall, it's still the cables just to do basic AI machine learning was missing. And so you can think about that's a workforce that needs to be trained. Then genome sequencing, having the equipment. That's another aspect. When I looked in the continent, when I called Illumina, who makes the sequencing machines, there was only one on the continent. That was 5 years ago, and I think now there's only about 3 or 4. So hasn't exponentially grown, and you're 5 times that in UAE now. So as you start to think about these things, those are the barriers that Africa is facing, yet it's the most genetically diverse continent in the world. And so you're missing, as we said earlier, a unique opportunity to create that environment where research and development can be done across borders with, federated data model. And then we took it a step further with IndyGeneUS, where we really started to look at technologies that were developed in other sectors like fintech, which is blockchain. So I'm a former FDA regulator, so that was very important for me to build that trust with communities that have not been quite trusting of the healthcare system like in the US. And so that was a key component when we did an MIT Hacking Medicine in COVID of highlighting the ability to build that trusting community with the privacy and security of blockchain and being able to show that data ownership for individuals. And it shows some level of transparency as well. It's able to show how data is being used for community so that in the future that can be also recognized from a economic and bioeconomic standpoint. So I think those are some of the areas that, again, IndyGeneUS Bio has really been drilling down on and talking to governments in Africa to make sure that those things are at the forefront if Africa wants to be one of the leaders in precision medicine. But what's clear is you have to go through Africa if you want precision medicine in the future.
That's a great point, and I think something important to highlight now is that, with the cost of sequencing ever decreasing, we're seeing data coming up in places where you wouldn't have previously expected. And we're reaching a point where almost every part of the planet can and has been sequenced to more or less level. And that's only going to increase, so the time is now for us to have these conversations and build the way forward. So we've gathered that collaboration is possible with the right structures, stewardship, and trust. And as we turn to our final section of this discussion, it's worth remembering that the Dubai Future Forum exists to explore systems that will shape tomorrow. In healthcare, no system will influence greater than AI in the next decade. The models we train today will determine who benefits tomorrow, and whether the future of precision medicine becomes equitable or exclusive. So with that in mind, Albarah, as AI becomes central to precision health, what new opportunities and even new capabilities does it create for countries like the UAE?
It's a great question. I think I just want to comment on one thing you mentioned. Genomics is becoming a commodity. Just a few decades ago, a whole genome sequence was in the tens of millions of dollars. Today, it's under $500 for a whole genome sequence. So to your point, it's becoming a commodity where even the smaller countries or the less affluent countries are able to sequence But then that brings other challenges. If you look at just the data set that we're sitting on here in the UAE, we're sitting on 120 petabytes worth of genomic data. To put that in context, if you take your home internet that we have today and you try to transfer 120 bytes worth of genomic data, it will take you 30 years, right, just to see the mass amount. So we have to, first of all, and the cost of storing data in a sovereign environment, in a secure environment, is massive on that scale. So hyperscalers, data centers can address these things, but I think we have to also change the way we store a significant amount of data through blockchain, tokenization, compression, and what have you, that we can bring this data to much smaller scale, but also generate the same insights. So that's one challenge we need to address, and AI can support that, because we can't scale and address the AI needs and the data center and the energy requirements for AI, as well as the genomic needs and the large hyperscalers requirement for genomics. So we need to find a new way of scaling genomics as it's becoming a commodity. Then secondly, I think how we envision it, we envision a global TRE. So we described how federating data in the UAE through a trusted research environment is critical for discovery, R&D. But I think what's really critical is if we're able to have G2G engagement models whereby each country can agree on having a global trusted research environment through federated data sets similar to the UAE and other parts of the world. This will allow us to address the inequity very quickly. Data today, to your point earlier, is extremely siloed. It's literally locked away in safes. Very little insight is being generated because everyone wants to keep that data for themselves. They're worried about losing control. It is purely that simple. They're worried about losing control. So how do we address not losing control but getting the most insights? I believe, and we believe at M42 and in the UAE, the best way to do this is cross-border collaboration through a federated trusted research environment. Imagine a world where you have all of these TREs sitting in 10 different places across Asia and Africa, and then globally you have a TRE that talks to all of these data sets. That in itself is an extremely powerful tool, and this is how we envision the future. And AI models will sit on top of that, and the discovery will be so much quicker, so much more precise, and ultimately so much more equitable. And that's how we envision it.
Fantastic, and that's a perfect segue, Man, into your domain expertise in governance. And which sort of governance principles should or must be built now to ensure that AI in genomics is reliable, fair, and globally applicable in the years ahead?
Yeah, I mean, the conversation that we're having, and I think we talked a little bit about that earlier, the conversation that we're having about AI reminds me a little bit of the conversation we've been having about genomics 20 years ago. When I first started, it felt like what genomics was to biology is what AI is to data today. You're talking about hype, you're talking about abundance of data, and you're talking about the ethical, legal, and policy issues that need to be dealt with in anticipation. But I think truly innovation comes when you have the right conditions. I laugh sometimes with my colleagues. They say, in Montreal where I live, we walk on water. And they're like, what? I'm like, yeah, come in January, you'll walk on water because we have the right cold conditions to allow that to do that. And I think it's the same here when we're thinking about innovation in this particular field. We have to first start with inclusive, responsible use of AI is not just a scientific imperative, it's an ethical imperative. And if we're thinking about the general principles that we can work with, it always basically revolves about how we keep and sustain this trust, right? So you can think of general principles around transparency, right? And transparency in AI, you're talking about explainability as well. This is something that you see more and more often in international and regional legislation as well, but you need to also put it in practice. Think about reciprocity. Think about benefit sharing, right? Think about equity, of course, right? So these are the principles, and the best way to do this, we can always, sit, in our own countries and legislate, which is unavoidable, and it's going to happen. But if we actually do this through an international consensus-building approach, then we come back to this notion of interoperability and this notion of shared universal principles, right? So rather than have a risk-based approach for legislation, You can have a principle-based approach in legislation, right? And that principle will base itself on these conversations and these deliberations. So the more we are able to include these voices, the more they're going to be heard, they're going to be around the table, and the more they're going to impact as well this global policy.
Absolutely. Thank you. Yusuf, going back to the continent, how do you see AI enabling Africa to accelerate its contributions to global discovery and future precision medicine, particularly given the challenges we just said about capacity building, what Albarah highlighted of infrastructure, compute power? How do you see that playing out?
Yeah, no, again, I think as we highlighted, right, is to getting the continent as a whole to start realizing the importance of how important the next 10 years for Africa could be in this sector, right? If we're talking about genomics and the historical facts that are true, that life started in Africa, and you can see where the importance of, you know, all 54 countries understanding that, and like what Ma'n said, start to understand policies and build infrastructure so that those communities that need to be engaged in a community are also brought to the table from a literacy standpoint. From the capacity standpoint, again, I think just overall, African governments have always relied on the West and others to fund these things, research and development, right? And I think you've seen the political landscape and climate from funding aspect have kind of changed. And so there's a new mindset for the continent to start thinking about how to build the level of economic stability through, you know, resources like they do with cocoa, the oil. And so as a commodity base, as was mentioned, that's what Africa needs to start realizing, that that may be an economic benefit for them to advance and put resources behind building the capacity in Africa. Because again, I don't see it, maybe someone else could share that with me if they see another vision or another world where precision medicine happens without Africa being involved, UAE being involved, and, you know, other countries being involved to bring that genetic diversity. And so I think that's an education piece for the governments in Africa to realize the importance of how Africa is one of the key players in driving the precision medicine. I think, you know, again, what IndyGeneUS Bio has always tried to do is make sure that we're keeping that at the forefront and being able to leverage the fact that technology and innovation like AI needs to be trained on more diverse data. It's just, it doesn't go hand in hand, right? And so if we understand that AI needs those models, the diversity of women and, you know, Asians, Africans, then that becomes where the power, where I see AI being astronomical, because without that diverse data set, we'll just end up with a more supercharged, you know, biased data set that really doesn't help anyone globally.
Yeah, and I think you raise a valuable point about genomic literacy. And, you know, I salute all of you here because you're taking steps to understand more about genomic literacy and how it's actually going to impact you in your own lives, particularly as we all age. And I think that's the conversation that needs to trickle down, as Albarah said earlier, from the bottom up, where genomic literacy becomes something that, a conversation piece for people to actually take some sense of ownership in that journey and in that process. So with that, it'd be wonderful to open up to the floor and take a few questions. It'd be great if there's some forward-looking questions that we can challenge our panelists with. Welcome that, if we've got the mics. Yeah. Thank you.
Right. My question is to the second speaker from the left. And you mentioned something around, you know, international consensus for us to be able to embed trust and equity and all those things. And I'm wondering what do you think the strategy will be, especially because that hasn't been there. And obviously, the world is sort of like constructed on a basis of inequality and disadvantaging some people and not others. So how do you see that happening? Thank you.
Thank you very much. This is a question that has been on my mind for quite some time, and thinking about innovative ways we can do this. As you're right. I mean, I hope we are more representative than we were 10 years, but we're still not there yet, right? Some of the ways we can really do this is make sure that when we are building these organizations, that we just don't have a central, kind of place, which is usually going to be somewhere in the Western, in a Western country. But to actually have nodes that are there in multiple regions. I'm also involved with the Human Cell Atlas, and this is an approach that we've done where we have HCA Africa, where we have HCA Middle East, where we have HCA Europe and Asia, and so on and so forth. This allows for a lot of work to be done in the region that will then be fed and inform the discussions and deliberations that we're having at an international level. But I also do think that, when you talk to someone in a language that they can understand, you're basically kind of talking to you're touching their brain, but if you actually speak in their language, you're touching their heart. And access to a lot of this documentation, to a lot of these policies, can't just be in English or in French, or it has to be also in multiple languages. And this, helps, I think, sustain literacy, but also allows for this conversation to happen in a much more streamlined way.
Fantastic, thank you. Could we take another question? Yep.
Good afternoon. Thank you for the wonderful and very insightful discussion. We raised this question about genome literacy, and I think back to when Fitbits and Apple Watches were just becoming very common, and people were wondering what to do with that data. Maybe some of us are still wondering that. We'll have access to these databases, and hopefully if you are all successful in your work, it will be more equitable. What comes behind in terms of that massive literacy, because there's a huge layer of counseling that comes on top of genomics for it to be more massively actionable. The research is important, we need new medical breakthroughs, but what is the next step in the pipeline of actually making this actionable for the population as we bring them on board and expand that access? Thanks very much.
Thank you, that's a valid point.
Maybe I can address some of those. Absolutely extremely valid points. And this is something that we've been discussing on numerous levels. But when we looked at genomic literacy, we decided through the government here that this will start at school. So we're no longer thinking about educating the community through public awareness like when we started the program back 4 years ago. But we now want to build it into the curriculum of school to be able to embed the genomic literacy within school curriculum. That's number one. Number two is there's not enough human capital to allow us to really decipher the genetic information into clinical, actionable elements of pathways. So if you look at clinical geneticists, genetic counselors, and there isn't enough in the world to serve the needs. But what there is AI models now, large language models that will support in deciphering this complex data that needs to be validated, obviously, and needs to be in conjunction with a treating physician. But that will allow us to scale the impact this has on actionable outcomes. And lastly is democratizing this genomic data to the fingertips of the individuals and not the physicians. And I think this is important, how citizens can act in none of the true clinical actionable elements, because that should be driven by a clinical pathway and a physician, but how they can act on something that they have power to do on lifestyle, well-being, and it's related to their polygenic risk scores, related to their genome. This is where we can now start breaking those boundaries, giving that complex data in a simple format to citizens and individuals, giving support AI tools to physicians to act on actionable clinical pathways, and obviously there's all the R&D and the discovery element as well. And starting from an early age in schools from a genomic literacy perspective.
Absolutely.
Yeah.
Just take another question.
Yusuf wants
Oh, sorry, Yusuf, go ahead.
Yeah, no, I think great question. And so, what we're doing at IndyGeneUS Bio, like you said, human capital is not there. In the US and in Africa, 3,000, 4,000 genetic counselors. So AI will be another area that we use within our platform. But again, it comes down to the data, right? So giving you information may be a lot more beneficial, but women in the audience, you don't want a genetic AI model that's giving information that's for a male versus a female. So that we're not there yet. And so that's why IndyGeneUS is focusing on that diverse data set first, and then building these models that could inform you And so that's one of the things COVID really kind of highlighted is for individual patients, which I agree with, is for you to start taking more benefit. And so we believe in our platform that that individual will be able to, be more engaged with their health, conversate with their doctors. I don't know about you, but some places you go, everyone thinks that doctor knows it all. And we're starting to realize that that's not quite accurate and true given the burnout rates that they have and seeing multiple patients. And so being more engaged in what we've seen over COVID will also be able to transfer with the genomic literacy that goes into it, and then getting reports back that individually goes into your clinical records. So that's another area that we're looking to make sure we get that end-to-end so that you don't drop off. You get a report that you know nothing about, all gibberish on a piece of paper, and then that's no value as well, but also having that communication with each individual patient.
And actually, just a final point on that before we move to the question, is that the human piece, the fear piece of this, that people are often fearful of knowing, often because they're not quite clear about what they do next. And this is such an integral part of that genomic literacy part, is that education will address the fear, which is still a significant barrier, especially when you do community-wide engagement. Please.
Is this working? Yeah. I just wanted to ask how we change the behavior of scientists, because essentially scientists have shaped how this map looks behind you, right? And I've worked on a project with Genomics England with their data ethics team to really understand how this bias is emerging and how it's impacting detrimentally on most of the world on their health outcomes. So fundamentally, how do we change the system of science, and how do we educate scientists, because they are the ones that are shaping this map?
I would not say it's shaping scientists, it's where the funding comes from, I think needs to change.
Which is also just a human problem, right?
Well, exactly, it's a human problem. It's not scientific problem, it's a human problem. The funding has come from particular countries, particular areas, and that's led to this significant bias, right? So now the regulators need to play a role in saying we won't accept we need more diverse data sets, and we won't accept this. That forces the pharma, forces the industry to go more diverse. We need more population genome programs similar to the UAE to help get a more diverse data set. And naturally is when you would not accept a very unique data set as a regulator, therefore by default, these individuals now, these institutions will start now pumping a lot more funds into more diverse data sets. And I think that's just a simple fact of money. And we need to get more money into the continent in Africa and Asia.
And I would just add that having worked in the research space, researchers go for what's easiest to access. They want convenience. They want the data yesterday, and they want to have the least amount of sort of red tape and procedural and bureaucracy to get to it. So making the data available, but then also streamlining the processes of access is going to be a critical part of addressing that behavior modification of the scientist.
Yeah.
Thank you for raising that.
Yeah, and I think, we haven't touched the 800-pound gorilla in the room, but I will, since I'm a former FDA regulator. We're going to have to bend pharma a little bit as well. Because they're the end user, right? They're the driver, they're the money guys. And so, what I've seen over my career is that, pharma dictates a lot of this stuff as well. And so that's who we're going to make sure that comes to the table and understand that we need better diverse data set. Because again, they're the ones putting these medications out into communities, right? Knowing that it doesn't address individuals that doesn't look like others that the data set represents. So we're taking a different approach at IndyGeneUS Bio. I regulated these guys before, so I kind of have an inside baseball on how these operate. And I think that's where you're going to get a lot of the change from the science standpoint, because they're the ones funding a lot. Even when I was at the FDA, they spend a lot of money getting what they want. And I think we now need to try to change that paradigm, along with the FDA diversity plan, which is now on temporary pause for a little bit. But being able to recognize that pharma is the end game of making sure that the data, the medications that are coming out of these pipelines look like the global population.
Yeah, I'm an optimist. I think we need to do a better job at showcasing, because we do a lot of work on showcasing the risks of sharing, but I don't think we do enough about the risk of not sharing, right? And quantifying that in lives, quantifying that in diseases, it's very important. 15 years ago, you know, I had to sit with multiple researchers who were trying to come together for a consortium. And, you know, we proposed a model for sharing of the data. Nobody agreed to it. They were like, does that mean that I can control or say yes or no? And then we had to do a lot of work of showcasing, listen, if you don't do this, all of this endeavor is not going to work, right? So it's a conversation. I think it's going to take a bit of time, but I'm an optimist.
Thank you. Thank you all. We'll just jump now to a quick rapid fire for the panelists. So just a yes or no. Is AI today reducing genomic inequity? Albarah? Yes.
Yes, if we use diverse data.
Yeah.
We're not there yet.
Yeah. Interesting. So we go from a yes and maybe to a no.
It's not a yes or no answer then.
Yeah. Well, this is it. Next one, yes or no. Can sovereign data sets still drive global discovery?
Absolutely yes.
Yes.
That's a yes.
Hallelujah, we have consensus. Now, if we had to choose one word to best describe the next decade of genomics, would it be trust, talent, or technology?
Talent.
I'm biased. I did my PhD in trust and reciprocity in biobanks. I'll say trust, because I think without it, talent or technology is not going to translate into equitable global personalized medicine.
100% trust.
Yeah, I would say trust for me too. So look, genomics reveals our diversity, AI helps us interpret it, and collaboration elevates it. And the future of global precision health depends on ensuring these three forces evolve together, inclusively, responsibly, and for the benefit of all. With that, I'd like to thank you all for your attention, and please give a round of applause for our esteemed panelists, and also to thank the Dubai Future Forum for placing the spotlight on this very timely and future relevant issue. Thank you all for being here.